Right now, 4 billion miles from where you're sitting, a world that should be one of the simplest, quietest, most predictable places in the entire solar system is doing something that breaks the basic rules of planetary physics. Pluto is cooling its own sky, not because it's far from the sun. Every world out there is cold for that reason. This is different. Pluto has found a way to actively refrigerate itself, using nothing but a thin blue haze hanging in its own atmosphere, and it's doing it in a way that no other world in our solar system does. Scientists chased this idea for 8 years before they could actually prove it. When they finally did, in 2025, the people who confirmed it used a word you don't hear very often in planetary science. They called it a new kind of climate, not a variation on something we already understood, not a smaller version of a pattern we'd already seen on other worlds, something genuinely new. And that's not even where this story ends, because in the months since that confirmation, the same telescope went back through its own archive and found something else on Pluto's surface, something that, as of right now, cannot be explained at all. By the time this video is over, you're going to understand exactly what Pluto is doing to its own atmosphere, why it took nearly a decade to prove, and what the newest piece of this puzzle might mean for how we understand the rest of the outer solar system. Some of this is going to sound like it shouldn't be possible. Stay with me, because it is, and the data backs every part of it. Let's go back to where this actually starts, because you need the full picture to understand how strange this really is. In July of 2015, after a 9.5-year journey across billions of miles of empty space, NASA's New Horizons spacecraft flew past Pluto at more than 30,000 miles an hour. It had exactly one shot, no orbit, no second pass. A narrow window of a few minutes to capture as much as it possibly could before flying on into the darkness of the Kuiper Belt forever. What it sent back rewired what scientists thought they knew about this world completely. A massive, pale, heart-shaped plain stretched across the surface, smooth and strangely young-looking, next to ancient, heavily cratered terrain nearby. Mountains built from solid water, ice rose more than 10,000 feet into a thin, hazy sky, frozen so hard at those temperatures that it behaved less like ice and more like solid rock. And layer after layer of blue haze rose hundreds of miles above the surface, visible even when backlit by the sun. Pluto didn't look like a dead, frozen leftover. It looked like a world still in the process of becoming something. But New Horizons only got one look. It captured what it captured and kept flying, never to return. Whatever it missed on that single pass would remain a mystery for years because there was no way to go back and check. That's the situation planetary scientists were sitting in for most of the 2010s. They had one extraordinary but incomplete snapshot of Pluto's haze, and a theory about what it might actually be doing, with no instrument sensitive enough to test it. Here's where that theory came from, and why it sounded almost backwards at the time. In 2017, a planetary scientist named Xi Zhang, working at the University of California, Santa Cruz, looked at Pluto's haze and proposed something that went against the assumption most people carried into that conversation. On Saturn's moon Titan, which also has a thick atmospheric haze, that haze traps heat and warms the world underneath it. It acts like a blanket. Zhang argued Pluto's haze might be doing the exact opposite, not trapping heat, releasing it, absorbing sunlight during the day and then radiating that energy straight back out into space as infrared heat, faster than Pluto's extremely thin atmosphere could ever hold on to it. In other words, instead of a blanket, Pluto's haze would be acting like a radiator, actively bleeding heat away from a world that already had almost none to spare. At the time, this idea struck a lot of Zhang's peers as unlikely, and even if they wanted to test it, there was no instrument on Earth or in orbit capable of actually doing it. Pluto and its large moon Charon sit so close together in the sky that separating their individual heat signatures was, for decades, essentially impossible. Every telescope that tried ended up with a blurred mix of both worlds' heat bleeding into a single signal. So the theory sat there, published, plausible, completely unproven for the better part of a decade. Then the James Webb Space Telescope came online. Here's what makes Webb fundamentally different from a spacecraft like New Horizons, and why it was able to do something no mission before it could. Webb doesn't fly past anything and snap the picture. It reads light itself, breaking it apart into individual wavelengths to reveal the precise chemical and thermal fingerprint of whatever it's looking at. Pointed at a faint point of reflected sunlight billions of miles away, it can tell researchers what molecules are present, how warm different layers of an atmosphere actually are, and how all of that behaves over time, without ever leaving Earth's orbit. Starting in 2022, once its infrared instruments were fully calibrated, Webb finally became sensitive enough to do the one thing every previous telescope had failed to do. It could cleanly separate Pluto's own thermal signature from Charon's, sitting right next to it in the sky. For the first time, scientists had a tool that could actually go back and test Zhang's 8-year-old prediction properly. A team led by astronomer Tanguy Bertrand at the Paris Observatory took that opportunity and ran with it. Using Webb's mid-infrared instrument, they measured Pluto's atmosphere directly, isolating its thermal signal from Charon's for the first time in the history of observing the system. The results were published in the journal Nature Astronomy in June of 2025. And they confirmed almost exactly what Zhang had predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the very haze particles suspended inside it. The measured temperature came in at roughly 30 degrees Fahrenheit, colder than earlier models had expected, colder than anyone had built into their previous understanding of how this atmosphere should behave. Bertrand described their result in blunt terms. This is unique in the solar system. Zhang, whose prediction had waited 8 years for the technology to catch up, said it wasn't common in planetary science to see a hypothesis confirmed this cleanly, this long after it was first proposed. Sit with that phrase for a second. Unique in the solar system, not rare, not unusual, unique. Meaning nowhere else on any planet, moon, or dwarf planet we have ever studied have researchers found an atmosphere behaving quite like this one. Now here's why that actually matters beyond just being a strange fact about a distant world. Researchers studying this mechanism believe it might not be limited to Pluto. If a haze this thin, this delicate, can meaningfully cool an entire atmosphere, similar processes could be quietly shaping the climates of other hazy worlds we haven't studied as closely, places like Neptune's moon Triton. And there's an even bigger implication sitting underneath that one. Some scientists think studying this exact kind of haze-driven climate could offer real clues about what Earth's own atmosphere looked like billions of years ago, long before oxygen ever built up in our skies, back when hydrocarbon haze may have played a much larger role in regulating our own planet's early temperature. A dwarf planet most people wrote off in 2006 might be quietly holding a working model of the early atmosphere that eventually allowed life to exist here. That alone would be enough to make Pluto worth another look. But the haze isn't just cooling the atmosphere. It's also slowly taking Pluto apart, one molecule at a time, and handing pieces of it to a neighboring world. Here's how that process works, and it connects directly to one of the strangest relationships between any two bodies in the entire solar system. Even the extremely faint trickle of sunlight that reaches Pluto is enough to break apart methane molecules high up in its atmosphere. Those broken fragments don't simply vanish, they recombine into heavier compounds, forming a slow chemical cascade that eventually produces reddish-brown particles called tholins, which drift downward and settle onto the surface below. But some of that escaping material never makes it back down to Pluto at all. Roughly 2.5% of the methane leaking out of Pluto's atmosphere drifts across the roughly 12,000 miles of space separating the two worlds and gets captured by the gravity of Pluto's largest moon, Charon. Charon is tidally locked to Pluto in an extremely tight partnership. And because of the way it's tilted as it orbits, its northern polar region spends multiple decades at a time in complete darkness. That makes the pole an extremely effective cold trap. Escaping methane molecules drift in, freeze solid onto the surface because there's no warmth to keep them as gas, and sit there accumulating for years before sunlight finally returns to that part of the moon. Once sunlight does return, it doesn't melt that frozen methane away. Instead, ultraviolet radiation and cosmic rays break the frozen molecules apart and reassemble the fragments into heavier, more complex reddish compounds, locking that dark coloring in permanently. That's why Charon's poles are stained a deep, unmistakable reddish brown, darker than anything else visible on the moon, while the rest of its surface remains fairly ordinary water ice. Two worlds, locked together, quietly exchanging atmosphere and color for billions of years, in a process that doesn't happen anywhere else we've ever observed. So by 2025, the picture of Pluto had already been completely rewritten. Not a dead, frozen leftover. A world actively refrigerating its own sky, actively bleeding its atmosphere onto a companion moon, running a genuinely unique climate system that took nearly a decade of waiting for the right instrument to finally prove. And then, in 2026, Webb's archive handed researchers something new, something that, as of right now, nobody can fully explain. In June of that year, a team of researchers went back through Webb's existing observations of Pluto, data that had actually been sitting untouched since May of 2023, and looked at a narrow slice of the infrared spectrum that most previous studies had skipped over entirely, a tiny sliver of wavelength nobody had focused on before. Inside that overlooked sliver, they found a gap, a specific point in the light coming off Pluto's surface, sitting at almost exactly 511 micrometers, where something was clearly absorbing energy. Something real, something measurable, something with no known match. They checked it against every published reference of known molecular signatures they could find. Nothing lined up, not once. And then, almost by accident, they checked the same narrow wavelength range in existing Webb data of Saturn's moon Titan. The exact same gap was sitting there too. Two worlds, billions of miles apart, about as different from each other as two bodies in this solar system can be. Titan is a giant world with rivers and lakes of liquid methane and a thick orange atmosphere. Pluto is a small, frozen, nearly airless world sitting 4 times farther from the Sun. And somehow, both of them are carrying the exact same unidentified chemical fingerprint. The researchers ruled out one possibility almost immediately. This isn't something floating in either world's atmosphere. When they compared how the signal behaved across Titan's disk, they found it actually got weaker toward the edges, the opposite of what you'd expect if the substance were suspended in gas. That told them the material is sitting directly on the ground of both worlds, not drifting above it. And the 2 worlds aren't even wearing it in the same amount. On Pluto, the signal came in roughly 3 times thicker than on Titan, meaning the substance is considerably more concentrated there. On Titan, it showed up more strongly on the Moon's trailing hemisphere than its leading one, a lopsided pattern that hints at some specific ongoing process depositing or altering the material unevenly across the surface. What that process actually is remains completely unknown. The researchers have floated a few candidates, a mix of benzene with some other unidentified molecule, a form of frozen acetylene, an exotic compound called ketene ice. None of these has been confirmed. The paper describing all of this was posted to the preprint server Archive in June of 2026 and has not yet gone through full peer review, which means the scientific community is still in the process of checking this work before anyone puts a final name on it. I want to be completely straight with you about what that means, because it's easy for a discovery like this to get inflated into something it isn't. This is not evidence of anything artificial, biological, or built by another civilization. It's a real, confirmed gap in the light coming off 2 worlds, matching no known chemical signature we've cataloged so far. That's genuinely rare and genuinely exciting in planetary science. But an unidentified molecule is not the same thing as an unexplained visitor. Every serious candidate on the table right now is a naturally occurring compound, the kind of thing you'd expect to form slowly over billions of years, in an environment this cold and this far from the Sun. The excitement here isn't about mystery for the sake of mystery. It's about the fact that 2 completely different worlds appear to share a piece of chemistry we've simply never had the tools to detect before now. So how do you actually confirm something like this when the worlds carrying it are billions of miles away? Right now, you mostly can't, not directly. But there's a mission already scheduled that might eventually crack this open, at least for one half of the puzzle. NASA's Dragonfly mission is set to launch no earlier than 2028. And if everything goes according to plan, it will actually fly through Titan's atmosphere and land on the Moon's surface in 2034. Dragonfly is a nuclear-powered, helicopter-like vehicle built to hop across Titan's terrain, sampling material directly as it goes, carrying an onboard spectrograph specifically designed to identify chemical signatures exactly like this one. If Dragonfly identifies whatever is producing that signal on Titan, researchers believe the answer would very likely apply to Pluto as well, given how closely the 2 signatures match even with their different intensities. But that mission doesn't launch for at least 2 more years, and it won't reach Titan's surface until the 2030s, which means, for now, both discoveries in this story, the confirmed haze-driven cooling and the unidentified surface molecule, sit in the same honest place. One is proven and still being explored for its wider implications. The other is measured, real, and completely unexplained. There's no funded mission currently planning to send anything back to Pluto specifically. A return trip would take the better part of a decade just to arrive, and the outer solar system has historically lost out in funding decisions to closer, faster targets that can return results within a few years instead of a few decades. For now, Webb remains the only working tool we have, quietly checking back in on Pluto every few months, adding another data point each time to a picture that keeps getting stranger rather than simpler. Step back for a second and look at the actual shape of this story, because I think it's worth sitting with. A world that was discovered by accident in 1930 by a 24-year-old assistant, flipping between photographic plates at an Arizona observatory. A world stripped of its planetary status by a single vote in 2006, and dismissed by a lot of the public as an unimportant frozen rock. A world that, when New Horizons finally reached it in 2015, turned out to have mountains, plains, and a haze nobody expected. A world that took until 2025, a full 8 years after the theory was first proposed, for scientists to finally prove it's actively refrigerating its own atmosphere in a way found nowhere else in the solar system. And now, in 2026, a world carrying an unidentified chemical signature on its surface, shared with a completely unrelated moon on the far side of the solar system. Every single time researchers have actually pointed serious instruments at Pluto, it has turned out to be more chemically active, more physically strange, and more scientifically important than the version of it most people carry around in their heads. That pattern matters beyond just this one world, too. If a haze this thin can genuinely cool an entire atmosphere, and if two worlds this different can share an unidentified surface compound, it raises a real question about how much we're still missing across the rest of the outer solar system. Pluto sits inside the Kuiper Belt, a vast ring of icy debris beyond Neptune's orbit, home to hundreds of thousands of objects and an estimated trillion or more comets. Only one spacecraft, New Horizons, has ever ventured deep enough into that region to closely photograph any of its larger residents, and even that mission only managed close flybys of 2 objects out of the hundreds of thousands of similarly sized worlds believed to exist out there. If Pluto alone is hiding a unique self-cooling climate and an unidentified surface chemical, there's no obvious reason to assume it's the only object out there doing something like this. It's simply the one close enough, and the one we've pointed the right instrument at for long enough to actually notice. Here's what's actually worth watching going forward, because both threads of this story are still open. On the haze cooling side, researchers are now asking how far this mechanism reaches. Whether similar cooling hazes are quietly shaping the atmospheres of other distant hazy worlds like Triton, and whether studying it further can genuinely tell us something about the atmosphere Earth had billions of years ago, before oxygen ever built up in our skies. On the unidentified molecule side, watch for peer review. This finding currently lives on a preprint server, meaning it's public but hasn't yet been independently checked by the wider scientific community, a process that matters and is worth waiting for. Watch for any follow-up Webb observations that either strengthen one of the proposed candidates, benzene, acetylene, Keton ice, or rule them out. And on the longer horizon, watch for Dragonfly, a mission already funded, already scheduled, carrying an instrument built to answer exactly this kind of question, set to land on Titan in 2034. Until any of that happens, here's where things honestly stand. Pluto is, as far as we currently know, the only world in the solar system actively cooling its own atmosphere using nothing but the haze suspended inside it, a mechanism it took 8 years and a brand new space telescope to finally confirm. And sitting on top of that confirmed unique climate, there's now a second, completely separate mystery. A chemical signature with no known match, shared with a moon on the opposite side of the solar system, waiting for an answer that might not arrive for years. Not a hoax, not something being hidden from the public, just a real, honest gap in what we currently understand, sitting out there in the cold, 4 billion miles from where you're watching this right now. If stories like this, built on real published research instead of exaggerated claims, are what you come here for, subscribe and turn on notifications, because Webb is still pointed back at Pluto every few months. And there's a genuine chance the next round of data adds another piece to this puzzle. Drop a comment with which part of this surprised you most, the cooling haze or the unidentified molecule, because I want to know. Thanks for watching.